So this is 4.2, number 27. They want to know on what intervals is this function increasing and where is it decreasing. You should recognize this as a cosine wave that kind of just bounces up and down. So you should have a kind of a visual what's happening. Here are the important things you have to know. Where can functions change from increasing to decreasing and vice versa? If I asked you that, you should immediately say critical points. If you don't know that immediately and have a visual picture why, you're not ready. So you should have a visual picture why at critical points do functions change from increasing, decrease, vice versa. Nowhere else, only at critical points. So that's what we're gonna look at. So we need to find the critical points to find the possible locations where it changes from increasing to decreasing. We have a chain rule because that's not x. If that were x, it'd be a normal derivative. So what's the derivative of 3 cosine of box? -3 sine of box times derivative of box, which is 3. So that becomes -9 sine of 3x. Now, what's a critical point? When that function is 0 or the derivative is 0 and does not exist. So when does that equal 0? That's my question. Because we know the sine function always exists, so we're not going to have that situation. So divide both sides by -9, and it's still 0. So here's what you have to picture. Right here, what angles there get 0? And this is where unit circle comes into play. Your unit circle says at 0, pi, 2 pi, and on and on and on. But also backwards. So it's plus or minus these. You need to know that what angles get you a sine of 0? All of these. But this angle here is actually 3x. So to solve for x, we divide both sides by 3. And we get x equals to 0 plus or minus pi over 3 plus or minus 2 pi over 3 plus or minus, whoa, that was weird, plus or minus 3 pi over 3. And we stop there because I'll show you why in a second here. Wow, this is going to be a lot of work. Now, that's pi. My domain is from -pi to pi. Endpoints are not critical points. So these are not critical points. Only interior points are critical points. So those are the only possible locations where the derivative can change signs. So we're going to make a number line. And it doesn't have to be to scale, but 0's in the middle. -pi over, oh, whoa. I don't want to do it that way. 0, -pi over 3, pi over 3. -2 pi over 3, 2 pi over 3. And this is -pi and pi, because that's what that was. That's the outer edge. And you have to know x goes there, and f prime of x goes there. Now, I'm going to emphasize this a lot. You shouldn't be memorizing what goes here. You should understand why we put those there. These are the points where a function can change from increasing to decreasing and vice versa. Okay? You need to know what tells us increasing or decreasing. You should know if the derivative is positive, the function is increasing. If the derivative is negative, the function is decreasing. That needs to be automatic in your brain. It's got to be like, what's your name? You should be able to say your name immediately. You should have to think, my name is George. No, Frank. No, oh, it's Brian. No, it's immediate. These things have to be immediate. It has to be part of your thinking. If you cannot see it, you are in trouble. You will struggle with the rest of calculus. So if these are the only places where a function can change directions, well, not the endpoints, the interior points. Well, I want to check each region to see if the function is increasing or decreasing in that region. So some of you are going to have trouble with this. I'm going to do pi over 6 because that's between. And this is 2 pi over 3. I'm going to do pi over 2 is between, because pi over 2 is 3 pi over 6. That's 2 pi over 6, and that's 4 pi over 6. So I'm going to do 3 pi over 6 was pi over 2. And this is what? 4 pi over 6. I'm going to do 5 pi over 6. I'm going to pick nice angles that I know the sine, cosine, and tangent of because that's easier. And I'm going to do the same thing on the left side, but just negative values. Now, it doesn't have to be the values I picked. As long as there are any number in each region, we're okay. But I chose those because they're nice. But again, I want to say this. In the whole region between these 2 points, it's either always increasing or always decreasing. So all I have to do is check one point. If it's increasing at that point, it's increasing on that whole region. If it's decreasing at that point, it's decreasing on the whole region. Now, I don't have to find the actual sine and cosine, or sine, the derivative. I just need to find out if the derivative is positive or negative. So let's put in 5 pi over 6. If I put 5 pi over 6, that's going to give me 10 pi. Is that right? 5 pi over 6. Let me do this down here. So f prime of x is -9 sine. Oh, I forgot that negative. If I didn't have that, I would have been in trouble. So basically, you want f prime at 5 pi over 6. -9 sine of 3 times 5 pi over 6, which is -9 sine, that's going to be 2, 5 pi over 2. We cancel those. Okay, where is 5 pi over 2? Real quickly in our head.
Wait a minute, where did you get the denominator from? 5 pi over 2?
Because this 3 and that 6 cancel, leaving a 2.
Oh, okay, I see.
Okay. So pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2, 5 pi over 2. We're up here. The sign there is positive. Do you all agree? Positive 1? A positive 1 times -9 is negative. I know the derivative is negative there. And I'm going to keep doing this, replacing each one. This one's kind of tedious because there's so many points. There's usually not that many. So this one will be pi over 2. 3 pi over 2 is down here, which is negative. But a negative and a negative make positive. And as we go, this particular one is just going to alternate signs. You can test each one in the derivative. So visually, let me erase all this. You can kind of visualize what it's going to look like. Decreasing, increasing, decreasing, whoops. Yeah, decreasing, increasing, yeah. Well, that's positive. I am messing up. So that's kind of what's happening. Decreasing, increasing, decreasing, increasing, decreasing, increasing. So you kind of see why it does that. And then, just to give you more connections, we found where the derivative equals 0. What did we find? We found that point, that point, that point, that point, that point, that point. We were finding where the derivative is 0. And again, it should make sense why where the derivative is 0, it can change directions. Okay. So that is the gist of 27. Oh, we're not finished. We didn't answer the question. Okay, be very careful. We haven't answered the question. We made a chart we need to evaluate the chart and answer this. So to properly say, whoa, you would say f of x is, you have to use words here, decreasing, I will type, on what intervals? Negative pi to negative 2 pi over 3, negative pi over 3 to 0, and pi over 3 to 2 pi over 3. You have to give a reason why. Okay, I said it's decreasing, but when you do calculus, you have to give reasons. So f is decreasing. Why? Because f prime of x is negative on those intervals. That's your justification. So when we start doing FRQs, you're gonna have to explain not just where, but why. Okay?
Mr. Yoshika,
Yes.
on your